Hi friends, good to have you back at Sapima tutorial. I want us to solve the second question we have here on the board. I've solved this one in my previous video. Just check the link under this second video now, this second question. You will find the link to the first one. So let's go straight to this. So we are asked to solve the second derivative of this problem. What do? We are going to differentiate it 2 times. That is, after differentiating your derivative, you differentiate it again. So let's differentiate. Now, let's write it as y equal to, let's remove the square root. I will have 1 plus x squared. Because I have 1 as my numerator, I will take it as inverse, multiplying 1 over 2. Because of this square root, we are removing this square root, 1 over 2. So if we multiply, I will have y to be equal to 1 plus x squared raised to power minus 1 over 2. So to differentiate this, we solve function of a function, that is using chain rule, because you cannot expand this bracket. So the easiest way and the only way I'm thinking we can solve it is by chain rule. And chain rule says dy over the x is equal to du over the x times dy over the u. So we are going to get u, differentiate with respect to x, get y, differentiate with respect to u. Then we multiply the both of them, we get the derivative. So from there, what could our u be? We say let u be equal to the function I have inside the bracket, which is 1 plus x squared. Therefore, y will now be, y is equal to this guy, raised to power this. So since here is now u, that means I'll have u raised to power minus 1 over 2. Then let's differentiate. If I differentiate this guy, u with respect to x, 1 is a constant, so it's a 0. Differentiating here, I will have 2x. Let's differentiate here. The y with respect to u will give us, this minus half will come down, so I'll have minus 1 over 2 u. Minus half, we subtract 1. That is minus 1 over 2 minus 1. This should give us minus 3 over 2. We can perform it. So I'll have minus 3 over 2. Having differentiated, the rule says the both of them will multiply. So let us multiply this guy and this guy. So I would have 2x multiplying minus 1 over 2 u raised to the power of minus 3 over 2. Let's multiply. These two, we cancel these two since they are multiplying. So I have x times minus 1 to give me minus x u raised to the power of minus 3 over 2. But you recall, but our u is equal to what? 1 plus x squared. Look at it here. This is our u. So let's put it in this function. So I will have minus x into 1 plus x squared raised to the power of minus 3 over 2. So to differentiate this guy now, we'll be making use of product rule. That is the same rule I used to solve this one. If you look at it, you discover that this is similar to this. So we make use of product rule. This is my u. Product rule, we have u, and here is my v. So we'll be solving dy over dx will be equal to, we keep u and differentiate v with respect to x, plus we keep v and differentiate u with respect to x. All right, so just take note of what our u is and v also. Let's write it down. U is equal to minus x, whilst our v is equal to 1 plus x squared raised to the power of minus 3 over 2. So what do we do from here? Differentiate u first. Let's differentiate u. The u over the v will give us minus 1, because we are differentiating a variable that does not have a coefficient bigger than 1. The coefficient here is minus 1. Then let's differentiate v. Differentiation of v with respect to x. We are supposed to solve chain rule because this is function of a function. Look at this power. So this guy cannot expand. So we are going to solve this same thing we solved here, but we use the shortcut. I'll show you the shortcut. Differentiate inside this bracket. 1 is a constant, so it is 0, gone. Then differentiate x squared, we'll have 2x. Then differentiate the whole bracket as a function. That means this power will come down. I will have minus 3 over 2, carry the bracket and put back 1 plus x squared. Then this guy will subtract 1, minus 1. If I subtract 1, I will have, this is minus 3 minus 2 over 2. So I will have minus 5 over 2. Just perform this operation, you will get this. So having differentiated here, we multiply. This is multiplication. So 2 can cancel 2. I will have minus 3x, this guy, into 1 plus x squared raised to the power of minus 5 over 2. So having gotten our derivative of v and derivative of u, the next thing we do is to add the both of them. Add this to this, but keep u and keep v. So our u, don't forget, is minus x. Look at it here, minus x. So we keep it minus x, multiplying it against the derivative of v, which is this, times minus 3x into 1 plus x squared raised to the power minus 5 over 2 plus, add it to, keep this one v. My v is this, 1 plus x squared raised to the power minus 3 over 2. We multiply it against the derivative of u. Look at it. Derivative of u, which is minus 1. So minus x times minus 3x will give me 3x squared into 1 plus x squared raised to the power minus 5 over 2 plus, this one we multiply here, so we now have minus. This is minus 1 plus x squared raised to the power minus 3 over 2. Now, because this guy has a negative power and a negative power, we can write them as fractions. Remember, this coefficient will multiply the fraction. If you have ax inverse, it is same as a over x. So let's do that here. This minus will now go out. So I'll have 3x squared over 1 plus x squared raised to the power of 5 over 2. That minus is gone. Take note of this. Let's assume I have a square here and a is multiplying. I will write it as a over x squared. That is what has happened here. Minus, let's do the same thing here. But this one does not have any coefficient here. So it is 1 over, we have 1 plus x squared raised to the power of 3 over 2. So you can write this as a square root with the power of 3. Write this as a square root with the power of 5. And leave it like that as your answer. Thank you so much for paying attention to this end. Please, you can always go back, take the video back to understand what I solved if you are confused at any point. Please do one favor to me. Like this video, share it to your friends, and then subscribe to my YouTube channel. Follow me also on Facebook and TikTok. Bye.